Hi students, today I am going to discuss the 3D sharing in computer graphics. In last videos I completed the 4 different types of techniques under the 3D transformation, that is the translation and rotation, and third one is the scaling, and fourth one is the reflection. Now I am going to discuss the last technique, that is the 3D sharing in computer graphics. So what the sharing is nothing but it is the object size can be changed along the x direction and the y direction as well as to the z direction. So it is somewhat different concept compared to the previous one, because of the sharing concept to change the change the size of the given object. Actually, up to this transformation techniques, so the object cannot be changed the size. Even if you go to the reflection technique, the reflection is taken in the mirror order only, that is an 180 degrees, but it will not change the object. But here what we observed here in the sharing concept, so it will change the size of the object, and particularly in the x direction and x axis and the y axis and the z axis, those three are the different one. So not the equal direction and not equal to the size of the object. Now coming to this particular sharing is the concept to change the size of the object. So that is in whatever the unrelated portion, we are going to be separated one for that particular object, given object in the computer graphics. Now coming to there are different types of versions in the sharing. The first one is the sharing in x axis, second one is the sharing in y axis, and third one is the sharing in z axis. So now we are going to discuss the complete notations in the sharing concept is, so consider a point of the object O has to be shared in the three-dimensional plane is, we have to consider the initial coordinate object O equals to x volt, y volt, z volt, and sharing parameter towards x direction. So now we have to observe the three different types of notations. So in the sharing, because the sharing parameter towards the x axis is the different, the sharing parameter towards the y axis is the different, and sharing parameter towards the z axis is the different one. So here you can observe the sharing parameter towards the x axis is denoted by SHX. So this is the notation for SHX. So x indicates the x axis, SH is nothing but the sharing object. So here we have to be observed. So the sharing parameter towards y axis in the sense SH, and you can write in the suffix as the y. So this is the notation we can observe: the sharing parameter in x axis, sharing parameter in y axis, sharing parameter towards the z axis, that is the SHZ. Now we are going to find the new coordinate of the given object. So using the sharing option, the sharing technique. So after completion of the sharing technique, so what the new coordinates are becomes to the x new, y new, and z new. Now we are going to discuss the detailed clarification of this particular sharing. Now we go through the sharing in x axis. Now you can observe this is the reverse technique of the previous one, that is what we have to done in the reflection. So coming to the sharing, if you taking the sharing in x axis, there is no impact on the x axis, but it will goes to the impacted of the y axis and the z axis. So that means the values may be the changes. Now the x axis value doesn't change when you go to the when we are doing the sharing in x axis concept. So now the x axis concept is the x axis coordinate is the same. That's why here we can define the x new equals to x volt, and the y new equals to, you have to write some of the equations. You can observe here the y new equals to y volt plus SHY into x volt. So z new equals to z volt plus SHZ into x volt. You may be observed here one of the clarification here in the both values you should be considered only the x volt and y volt. That means so we have to do the sharing on x axis. The x axis is considered, but there is no impact on the x axis. The impact goes to the y axis and the z axis. So this is easy to understand. So when we are going to the sharing of that particular axis, that axis cannot be affected. The remaining two axes may be the affected. That is Here sharing on x-axis means, so there is no impact on the y-axis and the z-axis. So similarly you can write in the matrix order homogeneous form, that is an x nu, y nu, z nu and 1. So equals to, here you can observe there is no shx. Why it will not consider the shx is in the sense, so you can observe in this notation, in this notation there is no shx value because of the sharing on x-axis. That's why we don't consider that shx. So the remaining values are the same, that is an homogeneous matrix. Now we are going to take the sharing on in y-axis. Sharing in y-axis in the sense, so there is no impact on the y-axis. The remaining two coordinates may be the different axis, may be the different values can be derived. So that's why here sharing in y-axis in the sense, you can observe the y nu equals to y volt value. The y nu equals to y volt value, here you can observe. There is no change when we are going to the sharing in y-axis. There is no impact on the y-axis. So simply we can consider the y nu equals to the y volt. And coming to the x nu equals to x volt plus shex into y volt, and z nu equals to z volt plus shz into y volt. You can observe here also the two notations, common notations which we are using in the z and as well as to the x. So these two are nothing but the y value is taken because the sharing on the y value. That's why we need to consider the y volt value which is applied to the x nu and the z nu value. So the y nu is the constant value. Now you have to take the homogeneous matrix of this particular sharing in y axis. So there is no shy value here. Already we can observe in the previous one, there is no shx value when we are going to sharing in x axis. Now in the sharing in y axis, so there is no y value here. So shx is there, shz is there, but there is no shy value. So the remaining values are the similar. So we can observe this. So here it is a sharing on y axis. Now we go through the sharing in z axis. So the similar pattern, there is no impact of the z axis, but the y axis and the x axis may be the affected. That is it give the different values. Now the z nu equals to the volt z value, that is a z volt value. So what we can do here, but the z volt value can be used in the two notations of the x and y. Here you can observe that these two values are the z values. So the z value notation can be considered in the relation of the x and y volt value. So that's why here we can find the x nu equals to x volt plus shx into z volt, and y nu equals to y volt plus shy into z volt. So the z is impacted here. So that value is going to be taken to substitute the x nu and y nu value. But the impact, there is no impact, direct impact to the z value because of the sharing in z axis. And similarly we can write the sum of the matrix order, that is the 3D sharing matrix. So in z axis that we have to write here, there is no, here also you can observe in this matrix, in this value there is no z value. There is no z value because of the sharing on z axis in the sense. So we have to be considered only the shx and shy. The two values are here we considered, and the remaining values are the same, and into x volt, y volt and z volt and 1. The 1 is the unity value here. So here we can consider the sharing is the concept. We can change it, that's why. So every time the impact goes to that x axis is taken and sharing, it will not impact it. The y and z is impacted. If you go to the sharing on y axis, the impact goes to the x and z. If you go to the sharing on z axis, the impact goes to the x and y. Now we are going to take the practical problem. So the given problem, the 3D triangle with point 0, 0, 0, 1, 1, 2 and 1, 1, 3. So apply the parameter, share parameter 2 on x axis, 2 on y axis, 3 on z axis. Now the three different values are given here. So the sharing value x axis is the 2, sharing value of the y value equals to 2, and the sharing value of the z is equal to 3. Now we have to consider the old corner coordinates of the triangle is given, and the sharing towards the x axis, sharing towards the y axis, sharing towards the z axis is given. Now in the, for example, sharing in x-axis, there is no impact on the x-axis. That's why the x value is the similar to take x new equals to x old value, that is the 0. Now y value is calculated by the given equation, and finally we can find y value also 0, z value also 0, because of the A triangle first coordinate value is 0, 0, 0. So this is for the coordinate 1. The new coordinates are also the same value. So for coordinate B, and also we can calculate the 2 value towards the sharing value. X value is 2, sharing the x, y value is 3, sharing the y value is equals to 4. So in the, for the coordinate in 3 coordinates, so first we need to find the sharing on x-axis. After completion of sharing in x-axis, and here you may be observed the sharing on y-axis. This is the sharing on y-axis. Y-axis for the coordinate A of 0, 0, 0 and B of 1, 1, 2, and the C value is the different one. So we need to find the ABC, the new coordinate. So after completion of the sharing in x-axis, y-axis, and also we have to be taken the sharing in z-axis. So the z-axis for the all coordinates, that is a given coordinates ABC. So we need to change the z-axis is the sharing. So there is no impact on the z value, that z new equals to z old value, and the remaining are the same values. So we have to be find out in the last new coordinates of the z. So finally we can derive the new coordinates of the ABC after completion of the x sharing and y sharing and z sharing. And finally, so these 3 different values are derived because of, in the sharing concept, x value is the different compared to the y value is different compared to the z value. So that's why finally the object size can be changed, okay, along the x-axis, along the y-axis, along the z-axis. This is the concept of exactly the 3D sharing concept.